All right, so how does this apply to graphing? We have a few situations where we're going to need to solve for the intercepts and then graph. So we learned previously that we'll set each term equal to 0 and then solve. So for the first term, add 4, 3x equals 4, then divide by 3, x equals 4/3. We'll also set x plus 2 equal to 0, and then x equals 2. So our two solutions are x equals 4/3 or x equals 2. Same here, we already factored 6x squared plus x minus 15, so we're just going to set each term equal to 0 and then solve. So the first solution is that x equals 3/2. Set the second term equal to 0 and solve. So we have x equals 3/2 or x equals -5/3. We did look at a few examples where we had the same solution or we had something squared, like 7z plus 8. That's fine, just set 7z plus 8 equal to 0, then solve for z. And in this example, we only have one solution. You'll learn more fancy words for that later, but for now, it's okay if we just say that z equals -8/7. All right, last example. We're designing a garden for grounds of our high school. We want the garden to be made of a rectangular bed surrounded by decorative stone that'll have a uniform width throughout. The flower bed will be 22 feet by 15 feet, and the budget we have will allow 420 square feet of stone. Let's draw a picture. We have our garden. We have the decorative stone all the way around the outside. We know the garden will be 22 by 15 feet. And however wide this garden is, we'll just call it W. So if I were to slide that segment up that I just drew and push it all the way to the end, it would go right here, which is W. And I could do the same on the other side, and that's W. And then the reason that helps is because if I want to find this entire side length, I know that it's W and 22 feet and another W. So the entire side length equals 2W plus 22. And we can do the same going down the side because it's uniform throughout. So I know that this segment here equals W. This segment on the bottom equals W. And this side in the middle equals 15. So if we do W plus 15 plus W, we should be getting 2W plus 15. We are trying to solve for the price, so we need to find the values of W that will work. So we know, you can ignore this. So we know that we're going to have 120 square feet of stone. So I'm going to write that on the left-hand side. And we know that the area of stone that we're going to have is going to equal 2W plus 22 times 2w plus 15. But then we have to subtract the middle part, which has an area of 330 square feet, because that part will not be stone. When we factor it out, we should have that 120 equals 4w squared plus 74w plus 330, and then minus 330. So we have plus and minus 330. These are going to cancel. So 120 equals 4w squared plus 74w. But now we're solving a quadratic, so we have to have one side equal to 0. We're going to subtract 120 from both sides. And then we'll be left with 0 equals 4w squared plus 74 minus 120. And now this just becomes a regular old factoring question. All of these are even numbers, so I would factor out a 2 so you have smaller numbers to work with. You can divide the left and the right side by 2 so that the 2 goes away. And then it's just like what we did before. Multiply a and the c. We get negative 120. We're adding the middle term, so the bigger term will be positive. The entire factor pair list. It's a really long list, but the one we care about is one where we add together, then it makes 37, which is here. So then we draw the box. 2w squared minus 3w plus 40w minus 120. Factor the greatest common factor out between each row and column. And then we get the answer, or we get the two terms. I'll go up here, 2w minus 3 times w plus 40. And then we need to solve for w. So 2w minus 3 equals 0. Add 3 to both sides. Divide by 2. And then w equals 3 halves. We also need to solve w plus 40 equals 0, but this solution is negative. W equals negative 40. So we would call this an extraneous solution because it's not possible to have a negative width on a garden. So our answer is 3.5 feet.